simplifying a complex, confusing world. The Explainers, only on The Podcaster.
I can't claim to have ever been a science kid, but I've always had and will always have a very, very soft spot for biology. I think it's just such a beautiful discipline, and I'm in awe every time I read even the simplest thing from the subject. I feel very moved. So I think it's worked out perfectly that my first appearance on our series, The Explainers, has to do with a beautiful story of biology. And when I say story, I mean, oh my God, such a story. So for the next 20 minutes or so, just sink your teeth into this episode of The Explainers. Hi everyone, I'm Ahalya, and today we're talking about the 2023 Nobel Prize in Physiology or Medicine that was awarded to the mRNA vaccine duo, Katalin Kariko and Drew Weissman.
We help you understand the world. The Explainers, only on The Podcaster.
It is beneficial to have improved human life through discovered arts. That is the translation of the Latin phrase that is inscribed along the outer edge of the gold medals presented to Nobel laureates who have made significant breakthroughs in medicine or physiology. And this year, the honor, as we all know, was shared by Hungarian-American biochemist Katalin Kariko and American immunologist Drew Weissman for their groundbreaking work on mRNA vaccines. And I think we've familiarized ourselves with Kariko through the recent forward on WhatsApp about the brunette Nobel Prize winner in wire-framed glasses who was forced to retire by the University of Pennsylvania. But her story is so much larger than that. The tribulations, the calumny, and the triumphs truly reads like a movie script. I mean, who doesn't love a spine-tingling comeback story? In the words of the Nobel Assembly at the Karolinska Institutet in Stockholm that announces the winners, Katalin Kariko and Drew Weissman were awarded the prize for their, and I quote, discoveries concerning nucleoside base modifications that enabled the development of effective mRNA vaccines against COVID-19. The Institute's press release goes on to state, through their groundbreaking findings, which have fundamentally changed our understanding of how mRNA interacts with our immune system, the laureates contributed to the unprecedented rate of vaccine development during one of the greatest threats to human health in modern times. Now, these are vaccines that help the world move forward from the COVID-19 pandemic by ensuring the safety of millions of people. Now, there's a fascinating story behind the development of the mRNA vaccine, going back decades and leading up to the technology devised by Kariko and Weissman. So if we're going to really dive into this, we need to take a peek into the past first. So what is an mRNA vaccine and why is it so special? An mRNA vaccine has one primary function: to teach the body how to create a protein that triggers an immune response. Do you see what I mean when I said biology is so beautiful? Overwhelming to me. You're going to hear me freaking out many times during today's episode. But anyway, now we in India didn't have mRNA vaccines for COVID-19. In fact, the only approved mRNA vaccine in India, which was the locally developed GEM-Covac OM, was only approved this year. The COVID vaccines used in India, Covishield and the more controversial Covaxin, are different from mRNA vaccines. Covishield is a viral vector type of vaccine. Essentially, it uses a harmless virus to deliver the genetic code of the antigen you want the immune system to fight to the host's cells. Now, Covaxin is an inactivated vaccine. According to the information on the website of Bharat Biotech, which developed Covaxin, inactivated vaccines contain dead virus incapable of infecting people but still able to instruct the immune system to mount a defensive reaction against an infection. Basically, your old school vaccines for things like smallpox, measles, polio, and the like. The OGs, as it were. mRNA vaccines, on the other hand, take a different approach by teaching your body's cells how to make copies of certain proteins. If you're exposed to the real virus later, your body will recognize it and know how to fight it off. Now, RNA vaccines are not a new thing. As Drew Weissman himself clarifies, RNA was being used as a vaccine from the mid-1990s on. It's not a brand new thing. What's new is what Kati and I developed. And before moving on, I have to give you a warning. I'm about to dive into the science of mRNA and vaccines for a little bit, and I will try to simplify it as much as possible, but there's a ton of jargon coming up, and don't worry, I'm in the same boat as you. We'll trip together. Okay, so mRNA is the short form of messenger RNA. And RNA, if you paid attention in science class in school, is ribonucleic acid, a molecule present in most living organisms and viruses. It's made up of things called nucleotides. Now, RNA exists as single strands while DNA is double-stranded. So that double helix we picture when we think of DNA, well, RNA usually has only one of those, not two. And how do they all work in tandem? Well, there's a central tenet in molecular biology to demonstrate the flow of information at the molecular level. DNA makes RNA, makes protein. So here's a quick explanation of how important mRNA is to vaccines using this bit from an article in Wired.com. And I quote, "These molecules act like digital tape recorders, repeatedly copying instructions from DNA in the cell nucleus and carrying them to protein-making structures called ribosomes. Without this key role, DNA would be nothing but a useless string of chemicals, and so some have dubbed mRNA the software of life." Now, mRNA makes up less than 5% of the RNA in the body. The majority of it is rRNA, or ribosomal RNA. According to the NIH, mRNA is transcribed from DNA and contains the genetic blueprint to make proteins. And that's where mRNA's role in these vaccines comes in. mRNAs were discovered or identified in 1961. So artificial mRNA, created in a petri dish and delivered to the cells of patients through tiny packages called nanoparticles, basically provide the body with instructions on how it can heal itself. See? Beautiful. Also, an interesting aside here, we tend to believe that DNA was discovered in the 1950s by Watson and Crick. Not true. DNA was first identified in the 1860s, likely 1869, by a physician and chemist named Johannes Friedrich Miescher in Switzerland. Several scientists contributed to advances in the study of DNA, and in 1953, Watson and Crick reached their groundbreaking conclusion that DNA has a three-dimensional double helix form. So as you see, we love sharing new information here on The Explainers and popping the bubbles of what you think you knew. In fact, Brian recently enjoyed mansplaining the women's reservation bill in our previous episode, so check out that podcast on The Explainers as well after this one, of course. I know I've got you hanging onto the edge of your seat. Anyway, back to mRNA. So once it was identified in 1961, scientists found that it can activate or block protein production in cells and began studying it for medical benefits. So the researchers kept researching over the next few decades, and in 2005, new research showed that modified mRNA could safely deliver instructions to cells without over-activating the body's immune system. By then, mRNA was being studied in an attempt to prevent diseases like the flu, Ebola, Zika virus, and others. Over the next 10 years, more research led to the discovery of the structure of virus proteins that let viruses invade cells. And that meant that scientists could create the first stabilized proteins for use in vaccines that provoke a strong immune response to viruses. Then, in 2017, while studying a Zika virus DNA-based vaccine, American scientists found that gene-based vaccines, like those using mRNA, were safe and effective. The same year, some scientists published their findings from clinical trials, meaning the first tests in humans of mRNA-based vaccines for common infections like the flu and even rabies. And that paved the way for the development of mRNA vaccines. By 2019, Moderna, the American pharmaceutical and biotechnology giant, was already making plans for phase 1 trials of mRNA vaccines for the Nipah virus. Those trials would commence in 2022. Whew, that was a lot of science. What? I don't mind getting a bit nerdy now and again. So now that we know the history of mRNA vaccines, what do we know about the benefits of these vaccines? I mean, there have been other vaccines that have been solving health issues for many years. Well, a 2018 article in Nature magazine claimed that mRNA vaccines offer three advantages. Firstly, mRNA is a non-infectious, non-integrating platform, so there's no potential risk of infection. Second, various modifications make mRNA more stable and highly translatable. And third, maybe the most important one, mRNA vaccines have the potential for rapid, inexpensive manufacturing that can be easily scaled up. And that brings us to Kariko and Weissman's breakthrough. What was the breakthrough? That 20 plus years of research led to a critical discovery. Surrounding the mRNA in a particular lipid prevented inflammation and allowed mRNA to do its job. I will explain that in a bit, but I started today's podcast by saying this is a story, and it begins with Kariko.
We help you understand the world. The Explainers, only on The Podcaster.
I mean, the road to this discovery reads like a thriller, and don't be surprised if you find a series on Netflix or a film in Hollywood based on her story, okay? I'm calling it here. It's probably going to happen if it's not in production already. Anyway, back to Kariko. Now, with all due respect to Drew Weissman, Katalin Kariko is a very fascinating protagonist. She possesses a joie de vivre bordering on effervescence, and yet exudes empathy and optimistic stoicism that are perhaps a result of her ordeals. Now, Katalin Kariko was born to a butcher and his bookkeeper wife in 1955 in a small town of 10,000 people in Hungary. This was the 1950s, so Hungary was behind the Iron Curtain. And that meant life was harsh, and it was easy to end up with a go-nowhere job. Kariko's childhood home had no running water, so it was a pretty meager existence by European standards. Yes, it's still better than India at the time, or rural India even now, but you have to admit, not comfortable at all. And also, just for comparison, Hungary had a per capita GDP of $2,480 in 1950, and that's what India's per capita income was in 2022. Yeah, I'll give you a second to digest that. Okay, so you see, pretty broke, all things considered, if you lived in the pastoral climes of 1950s Hungarian countryside. At an award ceremony in November 2022, one of Kariko's favorite songs by Hungarian singer Zoran played in the auditorium as she made her way to the stage. It was her go-to music during tough times, and now she counts the singer among her friends. As that famous rapper once said, started from the bottom, now we're here. So in her speech at the ceremony, she recalled her early years. She said, "I learned from my parents that hard work is part of life, and I learned how to make sausage. I was just a curious girl who watched with fascination all the plants and animals in our yard and wanted to learn more about the internal mechanism of all these living things. I didn't know a single scientist, but I was 16 and decided that I wanted to be one. My curiosity and passion swept me to biochemistry and fascination about mRNA. It's that inquisitiveness and her fascination, borderline obsession, with mRNA that would open the path to success, but not before she faced some serious strife. She completed a PhD in biochemistry in 1982 at the University of Szeged in Hungary. From 1978 until 1985, she was listed as an intelligence asset by Hungary's secret police. Yeah, secret police. But Kariko claims she was blackmailed into it. She moved to the US in 1985 to take up a research position at Temple University in the city of Philadelphia. Husband and a 2-year-old daughter in tow. The couple sold their car on the black market for $1,200, stitched the cash into the clothes of her child's teddy bear, and moved stateside. What did I tell you? Literally a thriller. You can't deny it. In 1989, she joined the University of Pennsylvania to work on mRNA. She was forced to leave Temple University after a disagreement with her boss, who also threatened to have her deported. Now make note, this is a bit of a recurring motif with Katalin, her calmness and tenacity in the face of hostility from her superiors. She recalls, and I quote, "1989, I started working with mRNA. The tech was not as powerful as today. Only a small amount of protein could be produced, which was seen by many people as irrelevant for any kind of therapeutic use. Over time, there were incremental improvements. We could see effects in mice, and we thought maybe it is useful for humans. Now, at the university, she would often take photocopies of journals, and that's where she met immunologist Drew Weissman in 1997. Drew was previously working for the NIH, and he was at the university conducting research on a vaccine for AIDS. Both fondly recall those early days when they were working in different departments at the university and would run into each other at the copying machine. "We would fight over photocopies," said Weissman, and they eventually got to talking about their work. Kariko said, "I helped educate Drew on RNA, and he was an expert on immunology. Working together, that was the real reward." Weissman concurred, saying, "I wanted to make a vaccine, and RNA was the way to do it, so it was kind of a perfect fit." But as Kariko's wiki page notes, before 2005, a major problem with the proposed therapeutic use of mRNA was that in vivo use led to inflammatory reactions. Now, in vivo means tests, experiments, and procedures that researchers perform in or on a whole living organism, say a person, a laboratory animal, or a plant. Kariko was intrigued that tRNA or transfer RNA did not cause the same inflammatory response as mRNA. And this was a ray of hope because most experiments with mRNA caused inflammatory responses from the immune system in test animals that led to immediate death. So not surprisingly, human trials were impossible. All she wanted to do was hunker down and work hard, but it wasn't to be. Maybe she's the perfect protagonist, a trouble magnet. Maybe the gods deemed her a destiny's child and tested her forbearance by putting her through upheavals. Maybe that would explain the crests and troughs she's had to endure. Whatever the case, Kariko found herself at the cusp of what Wired.com described as her lowest ebb.
Simplifying a complex, confusing world. The Explainers, only on The Podcaster.
Circa the mid-1990s, the powers that be at the University of Pennsylvania were growing impatient with her apparent lack of results in mRNA. Because coming up with a revolutionary vaccine is a job for a year, tops. Anyway, as Wired noted, frustrated with the lack of funding she was generating for her research, they offered the scientist a bleak choice: leave or be demoted. It was a demeaning prospect for someone who had once been on the path to a full professorship. For Kariko's dreams of using mRNA to create new vaccines and drugs for many chronic illnesses, it seemed to be the end of the road. Kariko recalls, "It was particularly horrible as that same week I had just been diagnosed with cancer. I was facing 2 operations, and my husband, who had gone back to Hungary to pick up his green card, had got stranded there because of some visa issue, meaning he couldn't come back for 6 months. I was really struggling, and then they told me this." It's also important to understand the intensity of the situation because at that point, Kariko was just a few years shy of tenure at Penn. It takes around 7 to 10 years for a professor to earn tenure, which is basically a secure, well-paying job for life. And it's a big deal in American academia. So Kariko's research seemed to be going nowhere, and her dreams were being thwarted even as a cancer threatened to end her life. All in all, not a great week for the spunky girl from Zolnok. And that is when she met Drew Weissman at the photocopier and eventually started a famous collaboration that would go on to change the world. So she took the demotion and settled for a lower salary in order to continue her research. "My salary was lower than the technician who worked next to me, but Drew was supportive, and that's what I concentrated on. Not the roadblocks I'd had to face," says Kariko, more an observation than a lament. The 2 colleagues soon came to a realization. The solution to creating a form of mRNA which could be administered safely was to identify which of the underlying nucleosides, the letters of RNA's genetic code, were provoking the immune system and replace them with something else. Sometime later, Kariko found a study showing that uridine, one of those components they were looking at, could trigger certain immune receptors. That was the crucial information she had been seeking. So in 2005, Kariko and Weissman published their paper on a specifically modified form of mRNA that replaced uridine with a molecule that looked the same but did not cause an immune response. In simpler terms, it opened the lines of communication between our body's cells and mRNA messages created by scientists. Kariko recalls their reaction on the day they realized they may have found the solution they'd been looking for. She told Wired, "I just remember Drew saying, 'Oh my God, it's not immunogenic.' We realized at that moment that this would be very important and it could be used in vaccines and therapies. So we published a paper, filed a patent, established a company, and then found there was no interest. Nobody invited us anywhere to talk about it. Nothing." Well, almost nobody. This is the scene of the movie where everything turns around. Their paper was read by a certain postdoctoral researcher at Stanford named Derek Rossi. He would go on to co-found this little company named Moderna in 2010. The company's goal was to use modified RNA in vaccines and therapeutics. And as of August 2023, Moderna is valued at $42 billion and is a major player in vaccines. Not too shabby for a bunch of researchers from Stanford, MIT, and Harvard. Meanwhile, Weissman and Kariko were in talks with a German company named BioNTech about using their mRNA tech. Katalin recalls those bittersweet years with some melancholy. For 4 decades, I worked quietly in the laboratory, performing experiments, wrote the lab notes, defrost the freezer. I knew what I was doing was important and didn't expect anybody to tap my shoulder praising me for my work. The only big ceremonies I attended was when my daughter won gold medal in rowing at the Beijing Olympics in 2008 and the London Olympics in 2012. Kariko recalls that at all the presentation ceremonies, she was Susan's mom. Now, going back to our protagonist's story, in 2013, Penn refused to reinstate Katalin Kariko to the full position she had some years ago in the university, the one she had been demoted from for lack of results. So she decided to work with BioNTech. And it seems like Penn officials at the time were the type to hold a grudge because they decided to rub some salt into the wound. Not only did they refuse to reinstate her to her original position, but Kariko recounts a meeting where they concluded that I was not of faculty quality. When I told them I was leaving, they laughed at me and said, "BioNTech doesn't even have a website." Every story needs a villain, people. Not one to be cowed down, Kariko gave a riposte that will become legendary in due time. In the future, this lab will be a museum. Don't touch it, she reportedly told her former boss when leaving her lab at the university for the last time. Go off, you tell them. The main reason she left Penn was a business deal between Moderna and AstraZeneca, the British pharma company. The $240 million deal was aimed at developing a vascular endothelial growth factor mRNA. Kariko realized she would not get a chance to apply her experience with mRNA at the University of Pennsylvania, so she signed on as a vice president at BioNTech while maintaining an adjunct professorship at the university. By 2020, as the COVID pandemic took over the world, mRNA was already being tested in other vaccines. Kariko explained that Moderna had already tested an influenza vaccine, which was an mRNA vaccine 2 years prior. It was just that the public didn't know about that. So the solution developed by her and Weissman was used to create the first vaccines for COVID-19. The data indicates that mRNA vaccines have a 95% efficacy in preventing COVID-19 infection. Now, BioNTech is a big name in pharmaceuticals, and big names like Moderna and Pfizer are working on mRNA vaccines in a way that will shape the future of medicine and therapeutics. A great vindication of Katalin's belief in RNA's importance. And for all of the lows, the highs don't stop there. The biggest, most meaningful vindication came via the University of Pennsylvania. Katalin Kariko is now back at Penn as a researcher. Penn's YouTube and other social media cannot stop claiming Kariko and Weissman as their own for the research work done by the duo at their university. I mean, you'd think an apology is due from the university, but there hasn't been one. Penn's social media has been showering praises on Kariko and Weissman incessantly ever since. So maybe that's the only mea culpa they have the courage to offer. The duo have received several awards over the last 12 months or so in recognition of their groundbreaking work. And brace yourself for what I'm about to say, but in the context of their story, the 2023 Nobel Prize in Medicine or Physiology is just the icing on the cake for the two scientists who persevered without sight of victory because they believed in what they did. Through all this, Drew Weissman has been a stable partner for Kariko. Ever the measured, stoic counterfoil to the bubbly Katalin, Weissman speaks in precise, concise sentences, never a word out of place, and always composed. A short video on YouTube shows Drew calling his parents on the phone after winning the Nobel Prize. As his mother showers praises, Drew betrays a few emotions as the joy of the moment really hits him. But that's pretty much the only time in these preceding months that his mask has slipped. Most other times, he's been happy to let Katalin grab the limelight. It's now customary for the Nobel Prize's social media team to share recordings of the first phone call to the laureates on YouTube. Many feign surprise and shock, probably out of politeness. It's quite a phone call. But, Katalin had reason to be skeptical. She'd faced enough recrimination already. What with all the pen shenanigans and the anti-vax noise on social media, do you remember that? Adam Smith, Chief Scientific Officer for Nobel Prize Outreach, called Katalin, who lives in a Philadelphia suburb, at 3:40 a.m. on 2nd October. Now, the usually vivacious Katalin could only muster terse, clipped responses, clearly more than a little overwhelmed by the phone call and the honor. She told Smith, and I quote, "As you know, 10 years ago, I was here in October because I was kicked out from Penn. I was forced to retire. My mother, who passed in 2018, always listened to the Nobel announcement. She'd say, 'Next week they will announce. Maybe you will get it.' My daughter saw me work hard and became like that herself. She's a 2-time Olympic champion and 5-time world champion in rowing and was inducted into the Hall of Fame. I was Susan's mom. Now she's introduced in award ceremonies as Katie's daughter." I don't really feel like saying anything more because that's such a mic drop moment, but this is one of those stories that makes history. Kariko and Weissman together have changed the world of healthcare forever. So I hope you found this episode of The Explainers worthy of your time. Thank you for keeping me company as I trip over the wonders of biology. We're going to bring you some more interesting conversations on another episode very soon. Keep an eye out for that. But in the meantime, stay safe and stay happy.
And I always introduced she's Susan's mom. I was Susan's mom. And now that my daughter came several times in the award ceremony with me, and she was introduced, Kati's daughter.
We help you understand the world. The Explainers, only on The Podcaster.